Hi kids, thanks for coming today. Guess what I got? I just dropped my son off at college. Well, actually, I dropped him off at a train station, so I didn't have to drive him back to college. How smart was that? When I do something smart, I drink Brugger's coffee. Oh, no 7 hours in the car for me today. Anyway, let's get started because you guys don't care about that. Hit the subscribe button, hit the like button, hit the comment button. Don't comment and say something mean. I don't want to know about something mean like I make a mistake or I'm dumb or heaven forbid you talk about my hair because that just really bothers me. And I don't know if you noticed or not, but I need a new computer. Oh my goodness. Every day I got to complain about it. So anyway, here we go. So we're going to work with, now I think this should be intuitive for you, but we're going to work with polynomial inequalities today. We've already had these on a spirals a few times because it's something that you've done a little bit with in algebra, and I was kind of hoping you could transfer some of that knowledge over into what we're doing now. But let's just walk right through this, and it won't take too long. It's a long video, I think. So here we go. First steps, we're going to take this thing, and what we want to do is we want to find out when it's greater than 0. And we're going to talk about what greater than 0 means in a few minutes. But the first thing we're going to do is just take a look at this quadratic right here. Now, we know it's a parabola, and so what we're going to do is we're going to factor it. Well, the factoring is relatively simple for this thing. It's x minus 4, x plus 3. And therefore, my two roots would be x equals 4 and x equals negative 3. So far, not too difficult, right? Hope not. We're going to prepare a number line that includes the roots. So what we're going to do is we're going to draw a number line and try to make it straight. And we got negative 3. And we've done this in the last couple spirals, so this should be nothing really new. You should have already worked with this. Now, in this particular case, since it is not got an equal to, this would be where it would be equal to 0, but since we can't equal 0. So what I'm going to draw this in. We have to make the decision, are we going to connect the dots? Is this the area where it is greater than 0? Or are we going to march off in either direction and say, okay, out to the sides is where it's greater than or equal to 0? I just don't know. And that's what we got to decide on. Why can I not? So I have to decide. Determine where the variables will be positive or negative. Now, greater than or equal to 0, this is going to be, and this is what I wanted to talk to you about. This is where it's going to be less than 0 is negative. Negative or 0. So we're looking for where it is negative. As far as, and I meant to draw that on top. So as far as what we mean by this, what we're looking for is negative stuff. Negative. Well, in terms of a quadratic, it is negative when it is below the x-axis. That's when a quadratic is negative. That's when the y values are negative. This stands for when it is positive or above the x-axis. So if I was looking at a quadratic that looked like this, it would be where it is above the x-axis in this area. Or, in other words, going in that direction and going in that direction. Now, if I decided to, and let me just show you this real quick, if it was an upside down parabola, and again, I asked where it is positive, it's positive where it is above the x-axis. So as far as what we're looking for, is this going to go up? Is it going to go down? Am I looking for in between? Am I looking on the outsides? And we're just going to base that on whether or not it's above and below the x-axis. Otherwise, I'm not sure what I just hit, where it is positive or negative. So in this case, I don't know where my pen went. Oh, in this case, we're looking for, we have a parabola that's going to go like this. So I'm looking again, where is this positive? Well, it is positive above the x-axis. So off to the right and off to the left. Not in between, but off to the left and the right. So if I go back to sorry, had a little brain fart there. Let me make sure we're recording. Okay, we're still recording. All right, good. All right, so now what we're going to do is we're going to shade based on the what we just did. So if I go back to my number line, we're going to shade off to the right and the left. In this case, we're going to, I can't do this, off to the right and the left. And in this case, where is it greater than or equal to 0? It's greater than or equal to 0 from negative infinity up to negative 3, not including negative 3 because it doesn't have an equal to, or from 4 to positive infinity. All right, there we go. That's that problem. So that's all we're going to be doing. So if you want to, before you even get, well, let's just do this. So what we're going to do is, the first thing we're going to do is factor. So x and we're looking for greater than 0, so x and x. And it's minus 5 and plus 1. So my two roots are negative 1 and x equals positive 5. So if I look at my number line, negative 1 and positive 5, and I think about what this thing looks like. Again, this is a parabola that goes up like this. So I want the parts where it is above the x-axis, or in this case, positive. So I want, again, on the outside. So open circle going to the right, open circle going to the left, and then it says, and solve and graph the solution set. Solve and graph. I also should state the answer. So in this case, it's from negative infinity to negative 1, union 5 to positive infinity. All right, moving on. Factoring here, it's just the difference of perfect squares, so this one's not too bad. It's just x plus 5 and x minus 5. So my two roots are plus and minus 5. So x equals negative 5, and x equals positive 5. So if I go on my number line, ka-ching, there it is, number line, negative 5's here, positive's 5 here. Again, we have a parabola that's going like this, right? And I want when it is negative or below the x-axis. So I want it in between. So in this case, open circle over. I want the part that's in between the 2 points or the two roots. All right, moving down. Oh, there we go. Finally, we got an E. So this one's not bad. This one's just x plus 1. X plus 7 greater than or equal to 0. So my two roots are x equals negative 1 and x equals negative 7. Number line, cha-ching, cha-ching, negative 7, negative 1. Of course, you know, let me take a look to see what this thing looks like. Again, this is a parabola that's going up like this. So I want where it is greater than 0, so I want this area right here. So open circle, going this way. Open circle, going this way. This parabola is x plus, excuse me. So this one is x and x, both negative. This one's minus 3 and minus 3, less than or equal to 0. So this is an interesting problem. We only have one root, x equals 3. Now, if you remember what the graph of this one looks like, if my root's here at 3, what's going to happen is a parabola that goes up, but only touches once. So where is it less than or equal to 0? Do you see anything down here? So in this case, the answer is, if I wanted to graph this, there's the graph, because it's only 1 point. My solution is literally just 3. That's the only place it is less than or equal to 0. Every place else, it will always be positive. So what happens if I decide I want to actually graph instead of equal to 0? I want to actually graph this. So, again, the TI Inspire does make this easier. Oh, that's a Newmanism right there. Where'd it go? This I heart calculator. So here's the quadratic x squared, and then so if I factor this would be x plus 1, x minus 1, right? So it's got two roots at -1 and +1. But I don't want a graph where it's greater than 0 or less than 0. I want a graph where y values are above or on top of or greater than this value. Well, if I want to do this on my TI-85, let me show you how to do it. I can just go through those notes, or I can actually just go through and show you how to do it. So what we're going to do is, normally I would graph x squared minus 1, and that just gives me this parabola. But that's where it's equal to. Then I don't want equal to. What I want to do is I want to change this equal to, in this case, greater than or equal to. And I hit enter, and now look what happens. It says, okay, we're going to shade above, because anywhere in here is where this is above the x-axis, is where the y values are above x squared minus 1, or the function value there. How would it change, though, if I just got equal to? Do you remember if we just get rid of the equal to? I don't know what happened here. Okay, let's delete this. Instead of that, let's just go greater than. What's going to change? Do you remember? It's hard to tell here. It should just be a dotted line instead of a solid line, but it's hard to tell, I guess, on that. So choose the appropriate symbol. Yep. So going through the steps that you would use on your calculator, what I would do on my calculator is choose the appropriate symbol, type in the equation, and then just graph it. And state the solution set. Well, the solution set is basically anything above that axis. Any point above that axis would work. Graph the inequality and state the solution set. I'm not worried about that so much. I want to just get a quick sketch on what this thing looks like. So if I had to graph this thing, I'm just going to give you a quick sketch of what this thing looks like. And then we'll take a look at it on the TI-85. So first thing you gotta do is find the roots. In this case, it's x minus 2, x minus 5. So my two roots are 2 and 5. So 1, 2, there's a root. And 3, 4, and 5. 3, 4, 2, 3, 4, 5. So they're my two roots. I also have an x-intercept up here at 10, or a y-intercept up here at 10. So my parabola is going to look like this. This is a quick sketch. Again, this is a sketch. I didn't give you graph paper, so I should have said actually sketch, not draw or graph. Because when I don't give you graph paper, I'm really looking for a sketch. So the question says, where are the y values less than this? Well, if I want to shade, then what I'm going to do is, oh, by the way, I just screwed up. Let me get rid of that. Does anybody know what I just screwed up on? I should have drawn a dotted line because it is not equal to. It does not have this equal to part right here. So, and then less than means we're going to shade down. You really can't state the solution set on this because the solution set is infinite on this. So when I ask you to actually state the solution set, maybe what I might ask you to do instead of state the solution set is state a point. I think what I forgot to put is a point in the solution set. So like, for example, the easiest point here would be pick the origin. Is the origin a point that works in this equation? Well, let's check it. Is 0 less than 0 squared minus 7 times 0 plus 10? Well, this ends up just being 0 is less than 10. Of course that works. And I can pick any point in this area way out here less than, let's say take the point 10, 5. I know it's kind of an annoying point, but the point 10, 5. So in for y goes 5. Is 5 less than 10 squared minus 7 times 10 plus 10? Well, this is 100 minus 70, which is 30. 30 plus 10 is 40. So 5 is less than 40. And so that works. So one of the things I'm going to ask you to do now is just quickly, can you recognize which graph goes with which? So didn't really lend this self to. So let's just say, let's take this one right here. Let's see if we can go find this one. Oops. Let's see if we can find this one. So this one here is, let's see, it's got a y-intercept of -6. It's going to be going down. And since it says greater than, I want to shade above. So I need to find a graph that's shaded above, it's going down, and has a y-intercept of 6. -6. Well, this looks like a possibility. This looks like a y-intercept of -6. It's coming down, and it's shaded above. I think that's our choice. Choice 8. So this one goes with A. So this one here also has a y-intercept of -6. It's going up because it's positive, and we're going to shade above because it's greater than. So we're looking for another one that has a y-intercept of -6, but we're shading above. So it could be 6. Looks like it might be 6. So this looks like B. This one here has a y-intercept of -2. It's shading up, but it's steeper because it's got a 2. Shaded up. And it's less than, so we're going to be shading below it. So we're looking for a skinny parabola that goes through -2, where we're shading below. And this is our skinny parabola. It goes through -2, and we're shading below. This is C. Positive. Y-intercept is positive 4. It's a parabola going up, and we're going to shade above it because it's greater than. And that looks like this, D, I'm guessing. And this one's upside down parabola with a y-intercept of 6. And we're shading below y-intercept of 6, and this would be, I don't know, E, right? Is that our last choice, E? E. Okay, not bad. Let's see what we got here. Not really sure how we got. Okay. So we got to go through domain. Let's talk about this. Domain is all reals. So -infinity to positive infinity. Range, -infinity to positive infinity. Roots are zeros. It looks like we've got a root here at -1. It looks like we got about a half. And let's just go 2.5. So it's an estimate. -1, a half, and let's say 5 halves, or 2.5. End behavior. As x goes to positive infinity, y goes to -infinity. As x goes to -infinity, y goes to positive infinity. That's describing the end behavior. Where is it increasing? Well, the only place this one is increasing is from here to here. So let's say from -1/2 to 1.5 or 3 halves. I think it was 3 halves. Let's go back. Yeah, 3 halves. And then from 3 halves going this way, and from -infinity to -1/2, it is decreasing. So we'll go from -infinity to -1/2, decreasing, or from 3 halves to positive infinity. Relative max. So what you're looking for a relative max is a hump that's a maximum. You're looking for a hump that's a maximum. And in that case, the relative max is at 3 halves. Can't tell if it's 3 halves 3 or a little above that. We have a relative max at x equals 3 halves, and a relative min at x equals -1/2. Where is it concave up? It's concave up from -infinity to 3 halves. Oh, no, actually, we got this point of inflection right here. At this point, it starts to become, at this point, halfway between these two, it starts to turn around and come back up. So let's not worry about that too much. I think we're going to, points of inflection. I don't think we're going to be using those points of inflections. That's a pre-calculus thing. Let's just not do that. I think I'd grab some of this too much from pre-calc. Yeah, there we go. I got rid of it. All right, so let's take a look. Let's graph this puppy. Domain is negative infinity to positive infinity. Use your calculator. We're going to calculator. Let's do this. X equals, oh, this is going to be a fraction, so we're going to use our calculator. So let me bring this over here. We'll get rid of this. Bye. So long. Farewell. Auf Wiedersehen. Goodbye. Oh my gosh. I am one sick puppy when it comes to singing, kids. There it is. There's our graph. Ooh, it's such a pretty graph. Control T. The only point that's not going to be on here is the vertex, and we're going to have to figure out what that is. But I know it's negative 1/2. See how it's between these two? So we've got negative 311, which we're really not going to get on, but just to kind of get a sense of where it is, that should be right about there. Negative 2, 3. Negative 1, negative 1. 0, negative 1. Here's our vertex. It's going to be right here. We're going to have to figure out what that is. And then 1, 3, and 3 are 2, 11. So there's our parabola. We have to figure out, we do have to figure out what that vertex is using our calculator. So we'll do that. That's not a problem. Oh my gosh, there it is. So again, the range, we're going to have to also figure out what that vertex is. So it's really important to figure out what that vertex is. Vertex. Now I know it's negative 1/2 something. I just don't know what. So let me get rid of this. Control T. And then we'll go to menu, analyze the graph, and we're looking for a minimum. We'll go left, go right. So it looks like negative 1/2, negative 1.5, or negative 3/2. So if I'm talking about my range starts at negative 3/2, and it goes up forever and ever and ever to infinity. Do I have roots? Oh, we got to find the roots. So let's round those roots. We'll round them up. Let's go hundreds place. So go menu, analyze graph, and we'll go to zeros. Now, again, click here, click to this one. You get 1.37. So negative 1.37. And then if I keep going over, it'll give me the other one, which is 0.37. So those are my two things. My y-intercept is easy. That's just 0, negative 1. Over, for what values of is f of x greater than 0? So it's a sketch on the number line. So again, greater than 0 means it's above the x-axis. So first of all, let's put our roots down. Our roots are at negative 1.37 and 0.37. Those are where our roots are. And we want greater than 0, not equal to. So we're going to do open circle, and greater than goes to the right and greater than goes to the left, because that's where it is above the x-axis. And above here means greater than 0. Down here is less than 0. Over what interval is it increasing? Well, it starts increasing here at negative 1/2 and forever and ever that direction. So from negative 1/2 to positive infinity, it's always increasing. Coordinates of the vertex. Well, we just did that. That was negative 1/2, negative 3, negative 1/2, negative 3/2. And this is really important. This should almost be first to find. Decreasing should be pretty simple. That's going to be from negative infinity, comma, to negative 1/2. Not including those turning points. Is the vertex a max or a min? Obviously, it's a min. And describe the end behavior. So as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. Oh, no, positive infinity. And that's because it's an even function. They're both going up. Calculate the average rate of change. So don't forget average rate of change. So this is just kind of coming back. That AROC, average rate of change, is equal to F at 0 minus F at -2 all over 0 minus -2. Well, the denominator is easy. It's just 2. F of 0 is -1. And F of -2 is 3. So minus 3. So this is equal to -4 over 2, which is -2. So over that change, it's -2. Now, if I come back to the graph and I look at between -2 and -1, clearly it's coming down, so I should have a negative average rate of change there. All right, let's move on. Tired of red. Now we got a cubic, so we know it's going to go. Now, based on our conversation yesterday, it's a positive cubic, so I know it's going to do something like this, right? All right, the domain is going to be -infinity to infinity. The range will be -infinity to infinity. We got to find roots and zeros, so we're going to need our calculator. So let's get into the calculator. Let's get rid of that. Click. Nope. Back into the calculator, and let's get it typed in there. X cubed plus 2x squared plus 2x minus 1. Clearly, I did something wrong. So let's hit the tab button and let's see if I can figure out what I did. Oh, look. I put everything in as an exponent. Wasn't that nice of me? Dum 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 dum. X cubed. So one of the things you want to make sure you do is get out of cube mode. Some of you are probably watching me put it in there going, oh my God, I can't believe this guy teaches math. He's such a moron. He's such a not a smart guy. That wasn't nice of you. All right, there's our cubic. So that's our root right there. We got our graph going like this. So what's the next thing we want to find? Roots are zeros. So menu, analyze the graph. Going for a 0. Click, click. There it is. 0.35. Let's just go with that. Y-intercept. Remember, this thing right here is always the y-intercept. So that's just 0, -1. I probably should graph this thing. 0, -1. We got 0.35. Anything nice? Let's go to table. Let's see if we can get any values in there. Let's see if there's any nice values. Ooh, 1, 4. 1, 4. That's a nice value. And let's see about any negatives. Ding, ding. Ooh, 0, -1. -1, -2. Any other nice values? -2, -5. That's probably the last one we're going to get. So it's going to look something like that. Just don't draw a straight line and try to hit the points. It's impossible to hit the points. All right. Sketch this on this number line below where it is less than 0. Remember, less than 0 means below the x-axis. So we're looking at all of this stuff down here. Well, that's anything that's less than this x-intercept. So in this particular case, we're going to go less than or equal to 0. So let's go 0. There's 1. And so 0.35 will be here. And I want anything less than that or equal to, so less than. Over what intervals is it increasing? This thing's always going up. So it's increasing everywhere. So when I ask for decreasing, that's the empty set. Nothing. Nothing. Nowhere. Describe the end behavior as x goes to infinity or positive infinity. Y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. I'm going to calculate the average rate of change. So we're going to do the AROC. Average rate of change is f of 2 minus f of -3 all over 2 minus -3. Well, the denominator is easy. It's just a 5-bagger. F of 2. F of 2 was 19 minus f of -3, -16. Well, those added together give me 35. over 5. So my average rate of change is 7. Okay. G of 10 to the nearest... Oh, this is the G function. I should have probably made these G's since it's the G function. G of 10 to the nearest 10th. What does it say over here? I don't know why. I don't think that's what I meant. I miswrote that question. Well, G of 10, I don't know why I said... I don't think I meant just 1219. I think I meant when... I think what I was trying to get at is when does G of X, and I'll probably have this reprinted so that it makes it look nice, G of X equals 10. And that's what I want to know when X is equal to, and I want you to round to the nearest tens place. Well, the easiest way to handle that is to go back to the graph. Let's get rid of our table. And what we want to include is we want to hit a tab and we want to hit 10. And we want to see where they hit. Well, if the highest I go is 6.7, clearly I'm not going to see that line I just drew. So I'm going to go into menu, change my window setting, and I want to just change my Y max to like, I don't know, 15 or something. And click enter. Oh, I meant Y max, not X max. Window setting, my Y max should be changed to 15, not my X max, but it doesn't matter. Okay, and so what I'm looking for is where do these things intersect? So I'm looking for the point menu, analyze the graph, intersect, click, and the round of the tens place is 1.5. So X equals 1.5. So that's the difference the way I ask the questions. If I ask G of 10, you just plug 10 in and you get an answer, but you wouldn't have to round to the tens place. So I'm going to change that question. Actually, I might just add the question just so you can see what the differences are. So, all right. So let's think about what this thing's going to look at based on what we talked about yesterday. It's going to be a even function. So an even function, they either both go up or they both go down. In this case, it's fourth degree even function, but it's got a negative out front. So we're going to look something, you know, maybe it has a couple wiggles in it, whatever. It's going to be coming down, both down. So let's go take a look at what this thing actually looks like. Red X, see you, wouldn't want to be So we're going to go negative X raised to the fourth plus 3X squared. No, we went cubed, you son of a so-and-so and such and such. Cubed. Get out of cube mode so you don't do anything stupid again. Plus X squared minus 4X. When I get bored, I start singing. So when I start singing, things get ugly. When things get ugly, the math gets ugly. When the math gets ugly, I drink Brugger's coffee because it makes me feel better. Besides, it keeps my mouth busy so I don't sing. Oh, look at that crazy function. Crazy. But notice we knew it was going to be coming down. You know, often both directions going this way. So we kind of knew that was going to happen. We should get a sense of what this looks like. So let's get these points. That looks like, let's go to the table. Control T. We got to get a few points that make sense. So negative 229, clearly they're not going to be able to graph. Negative 1, 0. So negative 1, 0. 0, negative 1. 1, negative 2. Two, 3. And 3, negative 4. So if you were just to look at these points, you'd be like, what in the world is that? So you really got to get an idea. Let's see. I really got to figure out what these points are in order to get a real solid graph of what these are. What are these relative maxes? Actually, that's an absolute max, and that's a relative max. And that's a relative min right there. Now, it's a relative min because it goes forever and ever down. So those are the absolute mins are negative infinity. But this is a relative min. It is a minimum point on a graph. So We should really get an idea what those are. Domain, negative infinity to positive infinity. The range, though, we have to figure out what this maximum point is. So let me get out of this table. We got pretty much all we can get out of that table. So what I want to do is I want to find out what these points are. I don't know why I hit that. So escape. Menu, Control T. I don't know why I just did that. Menu. We're going to analyze the graph, and we're going to look for the maximums. Let's look for some maximums right now. Click. Now that maximum is at, I'm going to find it. I need to see it. It's at negative 2/3 basically, and 1 point something, 1.1 basically. So negative, and it's a little over -1. So there's a point right there we're going to have to graph. And let's go find that other maximum, the actual absolute maximum. Click and click. This is our absolute maximum, so it's 2.25 and 3.6. Get this in there. This is our maximum. 1, 2.25, and 3.6. So probably somewhere around here. And it would be nice to know what our zeros are. Let's look. I mean, this isn't bad to graph over here. I mean, I'm looking at a graph, a zero that's just before 3. So if I put a little point in here just before 3. Somewhere around there. And this is going to be impossible for me to graph. And I know there's a point there. So here's how it goes. Comes down. Then this is a point where it's a relative max. And then I have a relative min at this point, and then I go back up here, and I go back down there, and I graph. So that's what it should look like. So the range, though, is, and we said that this maximum point was 3.6. So our range is from negative infinity to 3.6, and we'll include that point. Roots or zeros, well, I have a root at -1. I don't know what my other root is. Oh, I have 2 more. I have lots of roots. Holy mackerel. So we're going to go menu. We're going to go zeros. We got 4 roots here. So click here. There's the first one, -1. The next one is going to be -2.5. So -2 or 0.25. -0.25. My next one will be at all right, menu, analyze graph, 0, right here. Oops, what happened? Menu, analyze graph. I just gotta get a, come on, pen. 0, pen, dying, 0, click here. That one's at 1.45. So 1.45, 1.45. And I have one more. Menu, analyze graph, intersection. Not intersection. Menu, I shouldn't hit intersection. Menu, analyze graph, 0, left. And right, I can't see it. It's at 2.8. So my last 0 is at, I'm gonna have to stop this in a second and start over again, is at 2.8. How many imaginary roots does it have? Well, in this case, it's not gonna have any because the maximum number of roots it can have is 4, and it has 4 roots, so I'm gonna say 0. What is the y-intercept? The y-intercept is -1. Moving down. Where is it positive? So we're going to need those roots, and it's positive. Let me just highlight where it's positive. It's positive here and here. So if I'm going here, I'm going to put my roots in here, -1, -0.25, 1.45, and 2.8. So it's, what are we looking for? We're looking for when it's positive. So it's positive or equal to 0. So it's equal to 0 or positive between these 2 points, or it's equal to 0 or bigger than 0 or positive between these 2 points. Where is it increasing? Okay, so let me try to highlight when it's increasing. It's increasing from this whole area here and this whole area here. That green stuff is where it's increasing. So if I'm coming down here and I want to pick where it's increasing from negative infinity all the way up to that relative maximum, which I don't remember what it was. Do I remember what that was? I had to go maybe back to the graph and look. I didn't come up with this maximum. Oh, yes, I did. There it is. It's at so we use the x value, negative 0.68. So to negative 0.68. Or it's increasing from, now I don't think this was the maximum down here. We're going to have to figure out what this, I didn't figure out what that minimum was. So menu, analyze graph, minimum, click left, click right, and that's at 0.65. So from 0.65 to 2.28. So from 0.65 to 2.28, it's also increasing. Decreasing then would be from negative 0.68 comma to 0.65, decreasing, so because it's decreasing in this area. And it's, or from 2.28 to positive infinity, it's decreasing. Wow, that's a tough one. Calculate the average rate of change from this. So we're going to do h of 1 minus h of negative 5 all over 1 minus negative 5. Well, the denominator is 6. H of 1, do I even know h of 1? I don't think I can figure out h of 1. Let's go to the table. H of 1 is negative 2. That's not bad. Negative 2 minus, and h of negative 5. Did it say negative 5? Negative 956. So negative 956. So this is really negative 2 plus 956. So this is 954 over 6. Well, let's figure out what that is. 954 divided by 6. Oops, gotta go to the calculator. Calculator. 954 divided by 6. Wow, it's exactly 159. Calculate h of negative 1.5 to the nearest hundredth. So I guess the easiest way to do that is just take negative 1.5 and stow it into x. And then type in, oh, actually, no, that's a pain in the neck. Let's go to the table. I think the easiest way to do this would just be to go to the table. Control T. Oh, we got to go to the graph. Why can I not get to that graph? Let's get to that graph. And we'll go to Control T, and all we'll do is we'll go to Menu, Table, Table Settings. If I want negative 1.5, I'm going to say start this at negative 1.5, and maybe I'll make my increments by, I don't know, 0.1. So there's negative 1.5. It's negative 7.937. Round to the nearest hundredths. Negative 7.94. Negative 7.94. All right, I'm going to pause this. All right, just took a 2-minute break. All right, so I should have actually gotten rid of this one because that's a, ooh, man, was that a disaster. It's going to be interesting to do in class. Probably not going to get through all this in class, just saying. So let's graph this. 2x raised to the 5th. Now, wait a second. Before I even graph this, let's think about if we can figure out what this is going to look like. If I had to sketch this, it said sketch. Well, a couple things I know. Well, really working great. So I know that it's going to have a y-intercept of the origin, and you should be able to tell me why it will have a y-intercept of the origin. And that's because There's no constant at the end. I also should know that it's going to have some kind of wiggle and go up. Because it's odd and it's positive, it's going to go up. So my domain is negative infinity to positive infinity. My range is negative infinity to positive infinity. It could have upwards of 5 real roots or some imaginary roots. Let's go take a look and see what this thing looks like. Let's get out of exponent mode. We'll go to minus 7x squared minus 4x, and we'll hit enter. Ooh, I can't see it good enough, so let's go menu, window, and window settings. The x's are fine. The y's, we need a little bit more with those. So let's go negative 15 and 15. I don't know if we need as much x, so maybe we'll go negative 5, 2. That should be fine. Okay, I can see it better now. I can see that it's going to have 1, 2, 3 roots here that are real roots. That means it's going to have 2 imaginary roots. So real roots are real zeros. Oh, we got to sketch this thing. So let's get a Control T. See if we can get a couple of values. So negative 1, negative 5. Negative 1, negative 5. I hope that's right. 0, 0, we knew that was coming. 0, 0. 1, negative 9. And 2, 28. So that's it. That's all I got for points, and I don't know. I don't even know if that's a min or a max. So let's go through. I hate looking at this. So what we need to do is find some roots. So zoom. Let's get out of this thing. Control T. Let's see if we can menu zoom. I'm going to zoom a box, and I'm going to draw a box. Boom, boom. And I just draw a box around that so I can see these 2 roots. And now I want to find these 2 roots. I'm just going to find them. Analyze graph, zeros, click here. My first 0 is at negative 0.55. So I'll come back over here and I'll say negative 0.55 is one of my roots. My other one is 0. That's easy. Now I have another root. It's over here. So we're going to go menu, analyze graph, 0, click, click, and that's at 1.67. So 1.67. So at negative 0.55 and 1.67, I have some roots. So I mean, this is really what it looks like. Tough to sketch. I don't know if this is a minimum, so I probably should go find out if this is a minimum down here. I don't know if that's at 11 or at negative 9 or not. So analyze graph, minimum, click, click. Negative 1.2, negative 9.9. So actually it's a little bit past the thing. So this point down here is really, there's a minimum down here. So if this really comes down here like this, and then, oops, sorry, goes really steep back up. So a very tough schedule. Maybe I should not have used that scale factor. Maybe what I should have done, I'll do this in class. I'll just make every point 2 rather than every point 4. But if I was trying to do that, it'd be pretty kind of crazy. So how many imaginary roots does it have? 2. If there's a total possible number of 5 real roots, that means we're going to have 2 imaginary roots. The origin is the only y-intercept. Okay. Oh, I wish I had a new computer. Over what interval is it less than 0? So the critical numbers are negative 0.55, 0, and 1.67. So 1.67. So where is it less than 0? Well, it's less than 0 when it's over here in this area. It's less than 0 down in here. So basically, where is it less than 0? Well, it's less than 0 anytime we are going this way or anytime in between these two roots. Other than that, it's above 0. And if you think about it, here's where it's humping up, in between these areas where it humps up. And here's where it goes straight up. All right, over what intervals is it increasing? Well, it's increasing from negative infinity to negative 0.55. No, not negative 0.55. I apologize. Let me get rid of that. That's where it's... Okay, we got to figure out where this hump is here. I don't know if we figured that out yet. Did we figure that out? Let's go back to this graph. Did we figure out what this maximum was? We didn't figure out what that point is. We got to figure out what this is right here. So go menu, analyze graph, maximum, click, click. So negative 0.28. So it is increasing from negative infinity to negative 0.28. Negative 0.28. And where is it decreasing? Well, we figured out what this was. This was down here at 1.2. So union 1.2 going to infinity. Now, I don't know if it was exactly 1.2. Come on. .20. Yep. Okay, good. All right, we're almost done with this question, and hopefully done because my pen's about to die. Describe the end behavior as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to negative infinity. Over which intervals it is decreasing? Well, in between negative 0.28 and 1.2, it's decreasing. And that's the only time it's decreasing. Calculate the average rate of change. Okay, so we're going to do, what is this? J of 10 minus j of 0 all over 10 minus 0. Well, the denominator is 10. This is minus 0. So all I got to do is figure out what j of 10 is. So let me go over here to my table, Control T, figure out what j of 10 is. 199,260. So 199,260. When I divide those, I get 19,926. So there's my average rate of change from 0 to 10. J of negative 5. Now it says to the nearest thousandth. That's just silly because j of negative 5 is negative 6.405. And again, I want to figure out when does j of x equal negative 5. So what I'll do is I'll go back to my graph. Let me get rid of this. Control T. And I'm going to actually graph y equals 5. Can't see it yet. Must be somewhere around here. Oh, I already did what? Oh, I should have done y equals negative 5. Tab, dink. That's what I was screwing up. Negative 5. So there it is. When does y equal negative 5? It looks like it eats it. Wait a second now. I'll bet it equals it in 3 different places. 1, 2, and 3. So we'll have to find all 3 of those points of intersection. So let me zoom out. Zoom out. Okay, so now I can see all 3 of them. All right. So menu, analyze graph. We're going to find the points of intersection. Click. One of them's at negative 1. One of them's at 0.62, and the other one is at, so -1, menu, analyze graph, intersection, chink, 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 and then menu, analyze graph, chink, chink. And there's so much going on here. Oh, enough, big doggy. So we got 0.62, -1, and 1.55. So in this case, it would be -1, 0.62, and 1.55. All right, almost done. Two functions written in our graph below. What is the solution to the system of equations? Well, the only place that they're equal is right here. So the solution is 1, 0. That's the solution. 1 point. For what values of m of x greater than k of x? Where is it above? Well, it's always above here. It's above because this one's way, like this one's way down here. So from -infinity all the way up to, now above, at this point they're equal, and then k becomes above. So all the way up to 1, but not including 1. For what values of m of x is less than or equal to k? It's less than or equal to k starting at 1 and going off to infinity. And is that it? I think that's it. Nope. Which is the larger relative maximum? Relative maximum, okay. M of x's regular maximum is there, a relative maximum there, and k of x's relative max is there. So m of x has the larger one. M of x has the larger relative max. For what values of x is the difference between these? This is going back to what we did earlier. Is the difference between these two? Where is it difference between these things two? And I'm going to guess there's a couple of different places. There's one right here. That's the difference is +2, but there's also one right about here. But the difference between these two is -2. Remember, I'm asking when is m of k minus k of k equal to 0, and that's when x is equal to 0. And who has the larger average rate of change from 0 to 1? And we're going to look at this just graphically, from 0 to 1. So from 0 to 1, we're going to, oh, I can see. Okay, so what we're going to do is we're going to do m of x. Now remember, it's relative. I don't care if it's positive or negative. We're trying to look for the average rate of change. So m of x's average rate of change is going to equal, well, first of all, we're going to do 1 minus 0. And then at 1, this is 2. And at, I just screwed that up. Let me put the 2 points on so you can see them. We're going to use this point here, which is 0, 2. And we're going to use this point here, which is 1, 0. So we're going to do the average rate of change. We're really just doing the slope in between those things. So it's the change in y's, 2 minus 0, over the change in x's, 0 minus 1. So this is 2 over -1, which is -2. So the average rate of change for m of x is -2, and it's coming down. That should be obvious. Now the average rate of change for k of x is slightly weird because it goes up positive, then it comes down negative. So we're really going to use this point 0, 0, and 1, 0. So the average rate of change for the x's is 1 minus 0. The average rate of change for the y's is 0 minus 0. So this average rate of change is 0. So this one actually has the higher rate of change. Even though it's negative, it's got a larger rate of change. And it just asks for the large average rate of change. So in this case, m of x would have the larger rate of change. All right, kids, that ends day 3. I'm not getting through all that in one day. So we're going to see. Maybe we'll carry that over to some into day 4 because day 4 is kind of light. All right, kids, that's it. That's all she wrote. Catch you on the flip side, homie. I don't know what I'm just doing, so we're going to